Just got a new order for carbon dioxide laser cutter and engraver, you guys. This machine using MKS DLC board and a G-code license from Library, which working good on G-code file and vector file like I did with this machine. My new order is engraved portrait on this material using a DSP license from Library, which is compatible with Trojan board or Ruya board. And here is the DSP license from Library, and the price is good. And after making the result in my storage, these are some laser headset left from, some failed project. And this is why I call myself a machine compensator. And today's episode is for measuring, drawing, and repairing for raw material all the time. Now I'm starting with the second mirror supporter using line command, then extruding an 8mm part. And after measuring and drawing on those parts, I assemble them to each other to get the correct exact position. The same as before, I'm using an extrude command, then specify the wall thickness to make a regular base as you've seen. Next step, revolve a sketch profile around a selected axis, then specify the stand type, direction, and operation. Place a joint origin snap point on each component to position them, then adjust associated setting at joint limits and review joint motion. I'm using rejig to lock components together and remove all degree of freedom. Here is a tube supporter base, and the component just appeared is a tube supporter. Still using rejig to stick them together because they're gonna be fixed and have no movement on each other. A red one here is a simulated suspension for glass tube that is used to isolate a dedicated glass tube from a metal mirror supporter. Then link the whole glass tube and mirror supporter on the x-axis to check out that is there any problem or not. Checking out the distance between two pulleys, then moving an aluminum part and a UCB bearing on it until I get the two pulleys at their good and precise position. I have 4 alu parts and 4 USB bearings for holding and supporting the y-axis. Now, I'm calculating the appropriate distance between them on 3D workspace first. This is the first mirror and it's kind of too high for the plan of the aluminum profile. Then I'm gonna cut this one off to make it shorter. Before cutting in real life, I have to previously use 3D simulation to give me the length which I'm gonna cut off. After adjusting to get a good result for the first mirror, I jump in sheet metal environment to make for it a standing base. And for the standing base rigidity, I add an angle plate, then weigh it in a first mirror supporter base. The two aluminum parts for the y-axis are the same because of the simplicity. Joining this part on the linear rail and repairing for the x-axis installation. Inserting the x-axis that I have done before in this pool to make an assembly. Using rigid molding joint, as usual, pick the first and the second joint origin on each component and adjust it to get the job done. Before having any X and Y movement, let me connect the dual Y aluminum profile bars by using two 60-60 square steel bars. Let's jump in the sheet metal environment for some new update about the dangerous thing that may befall us. As I'm drawing, we need a second mirror supporter steel cover to prevent a laser beam from coming out unexpectedly. I didn't do that at first, but I get a ton of complaint about my design and the safety of our machine when it operates under our customer control. So, upgrade and change are inevitable. The second mirror supporter cover is divided into 3 parts and will be welded together for the rigidity. For the manufacturing, I have to unfold them, make them flat for laser fiber cutting. After that, the folding process will come to make our drawing come true. Having some last step of assembling the cover to check out any problem and deal with it on time. The upper frame for X and Y operation. Now I'm drawing the base frame for the upper one. Just having one type of steel bar for these two frames. It's 60-60 square. So we got a lot of empty space here, preparing for electrical box. And like I said before, I got a lot of failed project. That's why all these metal are on around my storage. And I should take this guy and make it become an electrical box. For measuring a real plate to 2D sketch, then become 3D plate in the workspace. Using a short command for a 50 and a 100 steel bar for an electrical box. Assembling a metal plate to check out the right position. Inserting our colorful electrical box using rigid joint for the base frame and the box. Then keep checking on every single side of this drawing to make sure that there's no problem at all.